Hello. Hello. Okay, I'm having a class. Then we now have technical issue. So we're now trying to. Yes. So the thing was echoing. So I tried to rectify it. So I'm sharing another screen now so that we can start.
Yeah.
Yes. Yeah, that's what I want to do. I'm trying to rectify it so that we can start. So we are starting in 5 minutes, please. Sorry.
Why you mute down?
No mute down.
Last night, he told me, "Oh, you're not supposed to have anybody. You're still young. You're still in school. You have to focus on this."
Okay. We are back. I've just got some assistance here to sort out the technical issue that is causing the echoing. Hello, can you hear me?
Yes, sir.
Yes, sir.
So this we stopped at this particular slide. I was trying to give us the standard integral. Of course, we were given in FBA 120. This will just serve as a revision before we start the application. The very first one, we all know that if you integrate 1, although the 1 is not written with respect to x, you will have x plus c. So also, if you integrate any constant, say a, with respect to x, you will have ax plus c. Of course, the integral is indefinite. You are not integrating within any limit. Also, if you are integrating x to the power of n with respect to x, we know that the integral would be x to the power of n plus 1 divided by n plus 1 plus c. And then if you are integrating the exponential form, ex, the integral remains the same, just as you have for the differential too. But if it is the integral of exponential ax, then the integral will be exponential ax divided by a plus c. So what we have on slide 7 and slide 8, they are the general form, the standard form for some function, including slide 9. So, so the properties of integration, you have been introduced to it at the 100 level. So if you are integrating, say, a function that is multiplied by a constant, it is advisable that you bring out the constant and then you integrate the function. Say if you are integrating 2x with respect to x, that it is advisable that you just integrate x on its own, and then whatever you get, you multiply by 2. So also if you have composite functions, or you have functions that are multiplying each other or adding each other, you treat them using some of the properties that have been introduced. Specifically, if you have two functions adding to each other, you can treat them separately, or you may add them. So let's take the example that we have on the screen. You have a function f of x. F of x there is 1 plus x, and then you have g of x. G of x there is 1 plus 2x. So it is easier for us to expand, and then you do the integration. Okay, so this you have done at the 100 level stage. So after the expansion of 1 plus x times 1 plus 2x, you will have 1 plus x. So then you will have 2x squared plus 3x plus 1. So if you are integrating, it's better you integrate each of the terms separately, and then you add the arbitrary constant c, because the integration is done indefinitely. So also, if you are integrating functions that are being subtracted from each other, f of x minus g of x.
Hello, sir. Hello, sir. Please, hello, sir.
Yes, can you hear me?
Hello,
Yes,
sir.
I'm listening.
Please,
yes,
please, sir. Please, sir, can you go to the previous slide?
Yes.
No, please, sir, can you go to the previous slide?
Yeah, you're already on the previous slide.
Yes, okay, yes, sir. Yes, sir. Thank you, sir.
So what's the question about this slide, please? Please ask your question about this slide.
No, sir. I just wanted to see, sir. Thank you, sir. I just wanted to see something there. Thank you, sir.
All right. Okay.
Thank you, sir.
That time. You have the slide on your phone.
With the
So
salt
I
example.
shared the material. I shared the material earlier. If you can't get it, talk to your governor so that you have your copy, please. So I was just giving a general overview, okay, of integration. The whole idea here is not to teach integration; it is to apply it. But of course, you can't just go ahead and apply if you have not done some revision. So we're just going through what you already know, okay? So you guys already know how to carry out integration using different conditions. So also, if you are to integrate, say, the square root of x plus the cube root of x, these are two different functions. Just as you have f of x plus g of x. So you integrate them separately. So you will integrate the square root of x. The square root of x is the same as x to the power of half. The cube root of x is the same as x to the power of 1 over 3. So the power of x for each of the term is 1 over 2 and 1 over 3 respectively. So of course you know that if you want to integrate, you will increase that power by 1 and then divide the new function by the new power. So you have x to the power of half plus 1 when you are integrating it. So the new power now is 3 over 2. So you use that to divide the function. Okay. So the second term, you also add 1 to 1 over 3. Right. So so use that to divide, and then you have your integral. Okay. So this you already know. All right. So also you have this problem x plus the square root of x all to the power of 2. The same way we have been advised, and expand the function after the expansion, and then each term will be integrated separately. So someone is raising up his hand. Shinene.
You use my second one. I'll die.
Why do you know?
Nice to
Your
one, so
hand
that
is up.
one's edited.
Hello, Shinene, your hand is up.
Good morning, sir. Good morning, sir.
Yes, please ask your question, please.
Sorry, sir. Please, sir. I am actually lost, sir, because I am a DE student, and I don't really understand the whole thing, sir. And you've been saying something we already know, and most of us, I feel like most of us don't actually know most of these things, sir, and I'm very confused, sir.
Okay. The students suggest that you did diploma, right? Or you did yes.
We did diploma,
I know
sir.
that yes, and I know that you guys did mathematics at
No, sir. At all, sir. We did not do mathematics, sir. For accounting, we did do mathematics.
You didn't do mathematics at the diploma or foundation level?
No,
sir. Foundation, sir. We didn't do mathematics in foundation.
Oh, okay. All right. All right. You see, I was supposed to teach you the application of integration to business. And as a form of revision, so that those that have forgotten some of the concepts will quickly recollect. That was why I am going through the concept of integration from first principle. So what I'm actually doing is going through integration from the beginning. Maybe I'm moving too fast. What I'm doing now is actually the integration. The basic integration form is presented in this table. I'm sure you can see it.
Yes, sir. Yes, sir.
So the three tables actually summarize the common integration problems that you can have. And I tried as much as possible to simplify it. So that if you are integrating any function x, what the integration says is that you will increase the power of x by 1, and then the new power that you have, you use it to divide the function. So if you have x to the power of 3, you are integrating that function, y equals x to the power of 3 with respect to x. That means it is the power of x that you will increase. So x to the power of 3 will now be increased by 1, it becomes x to the power of 4. And then the new power, which is 4, will now be used to divide x to the power of 4. So that's the idea behind the x to the power of n is, integrating x to the power of n equals x to the power of n plus 1 divided by n plus 1. So that n could be any number, okay? It could be whole number, it could be fraction. And then there are some other functions that have standard integral, like the exponential function, the trigonometric function, and so on. They have the standard integral, which have been taught at the 100 level. So what you need to do, if you are coming in and you feel that you have deficiency in this, is to quickly pick up a calculus textbook and just brush up. I'm sure you will catch up. Okay. So otherwise,
Sorry, sir.
Yes.
Sir. Is there a recommended textbook that we can use?
Okay, I will share I need a copy of a good textbook with you guys.
Thank you, sir.
So I'll chat with your class governor, and then
I'll go to my.
So or anybody, just send me a hi on my WhatsApp, and then I'll just forward it. But just make sure that everybody has a copy. Okay, so with that, you can easily catch up.
Can we get your WhatsApp number, sir?
Yes. Everybody has it already. So I'll type it on the chat after the class.
Okay, sir.
Okay, so
Okay, sir.
so I hope you appreciate why I'm moving at that pace. The whole idea is not to teach integration per se. It's actually to show you how to apply, because this has been done at the 100 level. Okay? So I hope you appreciate that. All right. So
yes, sir. I understand, sir. Thank you.
So we have discussed the application. Okay, the integral of composite function. How to simplify it and do your integration. So so now let's look at the business of the day. which is the application in business. The following functions, the functions displayed on the screen, they are common business functions. You have cost function, you have a revenue function, and demand function. Now, there's a relationship between marginal function and total function. The difference is that if you have a total function, for you to get the marginal, you will differentiate. If you have a total function, it could be total demand function, it could be total profit function, it could be total inventory function, any function at all. If you have the total function and you want to get the marginal is got by differentiating. On the other hand, if you have the marginal function and you are required to get the total function, the difference is in integration. You will have to integrate the marginal function to get the total function. I'll take it again, that there are several functions in business, okay, which includes economics, finance, and so on. If you have the total, you have your data over a period of time, and then you have studied it, and then you have developed a function that you feel represent that data. That function will be your total function because it takes care of all the available information. So if you are interested in the marginal, for you to move from total to marginal, you will differentiate that function. So the function could be revenue function. That is, you have total revenue function. But most of the time, the word total will not be added to it. So you just have revenue function. So also you will have inventory function, demand function. The total might not be added, but if it is added, fine. So if you have the demand function and you are interested in getting the marginal demand function, so for you to move from total to marginal, you will differentiate that total function to get the marginal function. So it could be total profit, it could be total revenue, it could be cost, it could be whatever function that have been defined. So the difference between them is integration and differentiation. So if I have the marginal, of course, how do I get the total? I will need to integrate to get the total. So, but you cannot integrate if you don't have the knowledge of integration. Okay, so which means that you must have done integration before you start the application. So what we are actually discussing, in this course, is the application of integration. So basically, we will apply it to functions that are in their marginal form or that are in their average form. Okay, so once you have the marginal, to get the total, you will need to integrate. Okay, if you have the total, to get the marginal, we need to differentiate. Right, so so that table that I'm displaying here, the table that you can see on the screen, summarizes everything that we will be doing. You see, that's why I said this course is actually one of the easiest courses that you'll be doing this semester. Okay? Very simple, straightforward, and easy to apply. Now let's look at what we have on the screen. You have the cost function. So assuming we have the cost function C, the total cost C of producing and marketing X units of a product depends upon the number of units. X is the number of units. So the function can be written as C of X. Okay, so the total cost, of course, we all know that the total cost will comprise the fixed and the variable cost. So the fixed costs are those costs that you incur irrespective of whether you produce a unit or not. While the variable costs are those that you incur that are dependent on the number of units of the product that is being produced. So the combination of the two will give us information about the total cost. So, of course, this is just explaining further what has been discussed, the fixed cost and the variable cost. So also you have the demand function.
Hello, sir.
Yes.
Please, sir, can you go back to the
Michael. So where?
No, the other one, sir.
Which one?
Yes.
This?
Yes, sir.
All right. Okay.
Yeah, I wanted
So,
to change it. Thanks, sir.
Is there any
Thanks, sir.
problem with this?
No, no, sir.
All right. Okay. So, so also the demand function can be clearly defined. The profit function can be defined. The profit function can be a function of revenue and cost. Or any other way that it has been defined. But generally, to be a function of revenue and cost. So you all know the break even. At that point, the profit is zero. So the revenue equals the cost. That you can make use of as necessary. So once your function is well defined, to move from your function, your total function to marginal, remember, you differentiate. You are moving from marginal to total, you will integrate. Okay, so that's what we'll be applying here. So let's look at the first example. So the marginal cost function of manufacturing X shoes is 6 plus 10x minus 6x squared. So the cost of producing a pair is 12 naira. So find the total and average cost. So the marginal function is given. Okay. And then there's an extra information. So a pair. So we all know what a pair is. It means that there are two of them, right? So a pair of shoes. So the cost, when x equals to 2, the cost is 12. So that's the extra information that you are given. But you are interested in computing the total cost. So remember, moving from marginal to total is about integration. But if you are moving from total to marginal, it's about differentiation. Now let's look at the solution. So the marginal cost is given 6 plus 10x minus 6x squared. That is given. So for you to get the cost function, which is the total, you will need to integrate. You will need to integrate. Now look at the function that you have there. I want to integrate 6 plus 10x minus 6x squared. This is similar to what we did earlier when you have your functions that you have expanded. So each term will have to be integrated, okay, to make it easier. Or as it is, you can just go ahead and integrate, and then you will have your answer. So that means you can integrate 6. You know, 6 is a constant. Remember the table, the very first table, that if you are integrating a with respect to x, what's the integral? The integral will be ax. So if you're integrating 6 with respect to x, it will give us 6x. All right? So if you're integrating 10x, if you check the properties of integration, the very first one that I've shown, that if you're integrating ax, that you just take the a off, integrate the x, and whatever you get, multiply your a with it. So the 10 stands on its own, so I'm integrating x. Of course, x means x to the power of 1. So the integral of x will be x squared divided by 2. So you multiply it by 10. So that gives us 5x squared. And the last term there is minus 6x squared. So we apply the same principle. 6x squared is the same as your ax, right? So take the a off, the constant, and then you integrate your x squared. X to the power of 2, the integral, you increase the power by 1. So if you increase 2 by 1, it gives us 3. And then you now divide by 3. So then that gives us 6x to the power of 3 divided by 3. And that is 2x to the power of 3. Of course, since we are integrating, we're doing indefinite integral, you're not integrating within any limit. You add the constant c or constant k to it. And that is our total cost function. So, but we need information. We need extra information for us to get the value of our k. Okay, what is the value of our k? So we shall make use of the extra information to get the value of our k. So what's the information given? Remember, we were told that a pair of shoe costs 12. And we all know that we know what a pair is. It simply means when x equals to 2. So when x equals to 2, c equals to 12. The total cost is 12. So you substitute into what you have there as your equation 1, and then you solve for k. So k will be equal to minus 4. So you are done. Your c will now be equal to 6x squared plus 5x. Sorry, 6x plus 5x squared minus 2x cubed minus 4. That is our total cost function. All right. So to get the marginal, to get the average, you will divide, just as you have been introduced to x bar. You know what x bar is? Summation x all over n. Is that not it? So which means that the total of all the observations, the summation of all the observations divided by number of observations. So if you are relating that to our cost function here, it simply means that the total, okay, the total cost of producing x units, x is the number of units that you are producing, divided by number of units that is produced. What is the number of units produced? It's X. So when you divide the total by X, you will have the average cost. Iganga, comfort.
Sir, I
Yes.
don't understand the marginal cost.
Okay, the marginal is the one that is given to us.
Okay,
It's
sir.
given in the question. So we are using the marginal to derive our total. And I said the relationship between them is actually integration. So if you are given the marginal and you are asked to get the total, what you need to do is to integrate. Okay, so when you integrate, you get the total. So if you are doing indefinite integral, you will add a constant c to it. So for that c to make sense, you need extra information. So the extra information has already been provided. That look, when x equals to 2, a pair costs 12. A pair simply means x equals to 2. So when x equals to 2, substitute 2 as x into that equation, equate it to 12, and then you'll be able to solve for the constant. So once that constant is known, we will now replace it back into our equation 1, and then that gives us the total cost. But the average cost will be gotten by dividing the total cost by the total number of units produced. What's the number of units produced is X, okay? So we divide it by X, and then what you have will be the total cost. Okay, so I feel that is very straightforward. Lillian.
Yes, sir.
Yes.
Please, I'm quite confused around this area where you said 12 equals to 12 plus 20 minus 16 plus k. Please, how did you get the 12 and 20 and 16?
Oh, okay. Let's go back to the question so that we can appreciate this. Look at the question. The question says the marginal cost function is 6 plus 10x plus 6 minus 6x squared. So it is given in the question, right? And then there's an additional statement. It says that the cost of producing it says the cost of producing a pair. A pair simply means 2, right? In terms of the number of shoes now, a pair. So the cost of producing a pair is 12. And what that means is that when x equals to 2, the total cost is 12. So this is an extra information. So if you move that to the application here, that means you have done the integration. After integrating, we got 6x plus 5x squared minus 2x cubed plus k. Now, if you substitute in x, when x equals to 2, all right? So 6x becomes 6 times 2. That's why you have 12 there. 5x squared becomes, what's x squared? 4. 4 times 5, 20. That's why you have 20 there. X cubed is 2 times 2 times 2, 8. 8 times 2, 16. That's why you have minus 16 there. Okay? Plus k. Of course, this is equals to 12. Where do we get our 12 from? Remember that when x equals to 2, the cost is equals to 12. It's in the question. So that's where we got all those information from. So I hope that is clear. Esther.
Yes, sir. Thank you.
Okay. So let's move to question 2. Let's move to question 2. Please feel free to ask a question.
Okay, sir.
I encourage students to express themselves, irrespective of how stupid we might feel that the question is. It's the students that have concern, and those concerns will have to be addressed. So please feel free to call my attention to any concern that you have. Ask your question anytime, please. Okay, so Lawal. Lawal, Oyindamola, you have question? Oyindamola Lawal, your hand is up. Okay, so let's move on. The second example, a company has determined that the marginal cost function for a product of a particular commodity is as given. So you have the marginal cost as 125 plus 10x and x squared all over 9. Okay, so and then you have extra function. There's a fixed cost for producing, and then you are asked to find the cost of producing 15 units. Okay, so, so the marginal is given, and you are asked to get the total. So what did we say about the difference between marginal and total? The relationship between them. We are given marginal.
Please, sir, can you go back to the question too?
Yes.
Now I get it.
Please, do you have a copy of the slide? Do you all have this slide?
Yes, sir. Yes, sir.
No, sir.
Yes.
No, sir.
Hello, no, sir. No, sir.
No, sir.
Okay.
We have it, sir.
It's on the group.
Speak for
Check your
yourself.
official group. Check your official group.
It's on the group. Check the group chat.
Somebody has sent to the group already. Go and check it.
Okay, so I understand it's on your
Check your
group chat.
official
Please,
group.
please. So please make sure everybody has the copy, please. So again, we have our marginal. So to get the total, you will integrate. So after the integration, you should have your 125x plus 5x squared minus x cubed all over 27. So I want you to confirm that you can get this on your own. But if you have issue, please let me know. You know, there are 3 times there. 125. 125 is a constant. It's like integrating A. What's the integral of A? It's AX. So the integral of 125 is 125x. So that one is settled. The second term is 10x. It's just like integrating AX. What's the integral of AX? It's AX squared over 2. AX squared over 2. So 10x, the integral of 10x is 10x squared all over 2. Of course, 10 with 2 will divide 10, and that will give us 5. So that's where the 5x squared is coming from. And then you also have minus x squared over 9. Minus 1 over 9 is a constant. You bring it out. Integrate x squared itself. If you integrate x squared, that will be x to the power of 3 all over 3. So the 3 will multiply 9 at the denominator. So that's where we are having the minus x cubed all over 27. All over 27 years. And of course, plus k. Why are we adding k? Remember, it is indefinite
A constant.
interval.
Oh, indefinite. Yes.
So it is as straightforward as this. So if you have questions,
Lawyer than small
please
handwriting.
ask your question.
Lawyer. I can't listen. I need a microscope.
Sir. What about the 250, sir? How do you come about
So do we have questions?
If I go and make
Yes, sir.
conflicts or custard.
I said, how do you come about 250, sir?
I bring that right one. I'll bring that right for me. Look at this one.
Hello, sir.
I think 250 is from the question.
The 250 is from the question.
Okay, thank you.
Excuse
Sir, please.
So
The 250 is the cost in the equation.
sir.
yes, the 250 is there. I see the question. Look at it. The fixed cost. That means the K is given.
Hello, sir.
Hello, yes, I'm listening.
Sir, please, how did you get the x raised to power 3?
And the 27.
Okay, the last term.
And
The last term there is minus x squared all over 9.
Yes,
minus
sir.
x squared over 9. So minus 1 over 9 is a constant. Do you agree?
Yes, sir.
So I'm integrating x squared. So
Okay,
if you
sir.
integrate x squared, it gives you x to the power of 3 all over 3.
Okay, sir.
So the 3 at the denominator of your x cube will multiply 9. So
Okay.
minus 1 over 9 times x cube all over 3 will give you x cube all over 27. I hope it's clear.
Yes, sir. Thank you, sir.
All right. So,
Excuse me, sir.
yes.
Sorry, please. My question is on the question of this the solution we did now, sir. Please, can you kindly help me go to the question, sir? I have a question there.
Yes.
Sorry, he said by MC the marginal cost equals to 125 plus 10x minus x squared over 9. But this statement where CV piece is the cost of 9 producing x units, I'm kind of confused. What does it mean? So where CV piece is the cost of 9 producing x unit of the commodity?
Yes. Change the unit. You know, the unit there is a naira. Just a C naira.
Okay.
Okay.
Okay. C naira is the cost of 9 producing x unit of the commodity. So what does that statement mean, sir?
The cost of producing.
So that
where
9
C naira is the cost of 9 producing x unit.
Okay. The marginal cost is 125 plus
10x
minus
x
squared all over 9.
Yes, sir.
Where C is in naira. Okay. This C is in naira for producing X units. Sorry, that's a mix up there.
Okay.
The 9 is not supposed to be.
C is in naira.
Okay. Thank you so much, sir. Now.
X units. Yes. Thanks.
Yeah, I get. I get now. Thank you so much. God bless you, sir. Thank you.
So, yeah, thanks for that observation. So the 9 don't have any role to play there. It's actually the cost of producing X units. X there will be the number in case we want to get the average cost. So you have to divide the total by X to get the average. So thanks. So do we still have issue with the solution? Please check.
No, sir.
All right, so let's move to the next one. So this time around, we have an extra function that has been introduced, the exponential function. Remember, as part of the standard integral, I also gave the example of the exponential integration. So if you are integrating AX, it gives you AX. But however, if you are integrating EAX, then the integral will be EAX all over A, right? So, but this function is straightforward enough. Now let's look at what we have. The marginal is 2 plus 5 exponential x. So you have to find the total function. So, and then what will be the total function when you produce nothing? That's like the fixed cost. When x equals to 0. So, and then find the average. The AC there is average. Remember, at the beginning, I gave you a table and I said that summarizes everything that we'll be doing. So the AC there is average cost. Okay, so of course, if we integrate, you will have our MC equals 2 plus 5x marginal cost. That's what is given. So if you integrate it,
Jesus.
Hey, you want flat out.
Oh yeah, Grace, let's go on. Grace, Takeni. She'll be gone. Buy this paper now. You know that's going to be that one. Yeah, put that one.
Hello? Do we have any issue with this?
No, sir.
Michael, do you have any issue?
No, sir.
All right. So I think this is straightforward enough. How do we get the average cost? You divide by X. This is the average. X is the number of units that was produced. MC is the total. Okay? Total divided by the number. That gives you the average. So this is straightforward. It's just unfortunate that we started very, very, very roughly.
Sir, please go back to the solution of question 3.
Okay, I should go through the solution again. And look at the solution. That was why I kept quiet for a while. I wanted you to have a look at it. There are just 2 terms there, 2 and 5EX. So if you integrate 2, it gives you 2x. If you integrate 5EX, it remains 5EX. Then you add k to it, that's all. The rest is you now have extra implication. So when x equals to 0, you will have your k, and then and that's all. So the total cost is actually 2x plus 5EX plus 95. Why the average? When you divide your total cost by x, it now gives you the average cost. And that's why you have the average cost as 2 plus 5EX all over x plus 95 over x. So it's straightforward.
Okay, sir.
So
okay,
and I've also prepared 65 questions. 65 question and answer.
Sir.
Yes.
Thank you, sir. Sir, I thought K was our fixed cost, and in the question, K was equals to 100. So why is K 95 here?
5 minus 1. There's no material for it, but I don't think it's the offset.
Hello, sir. Can you hear me, sir?
Yeah, I'm sharing the screen. I want us to be on the same page. Where is our K correspondent?
You go send material.
Yeah, when C is equals to 0, then that's when production, the quantity, we're not producing anything, it's only the fixed cost that we have. And that's 100K. So why did we have 95 as K?
The cost. The cost.
I don't understand that. Can you proceed?
I can't hear you. Sir, I can't hear you.
Application of.
Sir, I can't hear you.
Sir, we can't hear you, sir.
Yeah, I'll send you one that you asked for.
Okay. Hello, we are back now. So I wanted to get this thing clearly. Let's go back to our first example. Remember, in our first example, when a pair costs 12, Abi? A pair costs 12 means when x equals to 2, C is 12, right? It is the same as saying C of 2 equals to 12. C of 2 equals to 12. So when x equals to 2, C equals to 3. It's the same thing here. When x equals to 0, C is that, and then you plug it in, you have that. It is not a linear function like we had earlier. If it were a linear function, a K will just be automatically 100. But here, remember, you now have an exponential function there. So, and that's why the K is now 95. So, someone is trying to ask the question. So I said I've compiled. Okay, Grace Child. Who is Grace Child?
Hello, sir. I'm here, sir.
Yes, Ayodeji, yes. Ask your question.
Sir. The answer you wrote, like that is. Sorry, can you go back to slide, like the last letter? Yes, this answer that I wrote here, this AC equals to 2 plus 5E. Is that will leave the answer? If you have like solved it, is that will leave the answer?
No, the answer for look, there are two questions in one.
Okay.
The first question is total function. The second question is the average. So that C equals to 2x plus 5 exponential x plus 95 is the total cost function. And then the AC, remember the AC, the average cost. We got that one as 2 plus 5 exponential x divided by x plus 95 all over x. That's the average cost. So those are the answers. Where you have your C and where you have your AC. The rest are just workings.
Okay, sir. Thank you so much, sir.
So I said I've compiled 65 questions for you guys, both answers and questions with step-by-step solution. So that once I will share the link with you, you will have a look at it.
Okay, sir.
Before our next class.
Thank you, sir.
And then for our test too, for all the lecture that you've been having, I will prepare a Google form. So I will share the link.
Okay, sir.
I will share the link, and then I will give you 1 week to solve, because that's your continual assessment too. If you miss it, well, that's your problem. So when it is ready, I will make sure everybody has the link.
Hello, sir.
So sorry. Yes, I'm listening.
Sir, please, will you make the recording of the class?
Yes, I will.
Okay, thank you, sir.
All right.
Thank you very much, sir.
Okay, yeah. See you.
Don't worry. No.
Hello, sir.
I don't want to write again.
All right, thank you, sir. Bye-bye,
Sir,
sir.
you are the best. You are the best.
Sir, please, the next question, the example 4.
Yeah, the next question, you show the question.
Example 4.
I'll use it now.
You want me to go through the example 4?
Yes.
No,
Okay,
sir.
sir,
No,
you said
sir.
you
We'll study
Yes,
another
sir.
time.
Please go through it.
Go through it.
No, sir.
All right,
No,
so
sir. No.
bye-bye.
No, sir. No,
So I'll see you. Yeah, bye-bye.
Sir, you are doing the best too.
You guys want me to go through example 4?